Okay, we're going to do the chain rule today. The chain rule, chapter 4 is we're going to go deep dive a little deeper in derivatives. Okay, so 4.1 we'll do chain rule, and then 4.2 we'll do implicit derivatives. And then 4.3 is inverse trig functions derivatives. And then 4.4 will be the derivatives of exponentials and logarithmic functions. Okay. All right. So 4.1 chain rule. This is a fairly important concept. You guys often kind of forget to do this or do it halfway or whatever. So let's pay close attention here. All right, so on page 155, we're going to do the chain rule. Chain rule. So let's go look at example number 1. Example number 1 says, if I ask you to do the derivative of y is equal to 6x minus 10, and I ask you to what's the derivative of this? This is pretty simple, right? The negative 10 goes away, so all I have left is 6. So the derivative is 6. So basically, dy dx is 6. However, we can look at this as we can go ahead and say this is 3x minus 5. And we can go ahead and call this guy u. So this is going to be actually y is equal to 2u, right? And now I can say, well, dy du is equal to, if I take the derivative of this with respect to u, I'm going to get 2. But I also know that u is equal to 3x minus 5. And I can say that dx du, du dx, if I take the derivative of u with respect to x, what do I get? I get 3 here, right? So 3 times 2 is 6. So basically what I can say, because I can conclude that dy dx is equal to dy du times du dx. You see that? Now again, okay, the dy dx is not dy over dx, okay? We made that clear, right? Same thing here. This is not dy divided by du. This is dy du, okay? But however, you can see that they kind of go away and it becomes dy dx. Or in other words, I can say that dy dx is dy du times du dx. Okay, so let's keep that in mind. Let's move on to example number 2. So if this holds true, let's see if I can utilize this. And example number 2, it says what? The polynomial blah 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 is a composite. So we're going to say y is equal to 9x to the 4th plus 6x squared plus 1, which is the same as 3x squared plus 1 squared. Again, I'm going to go ahead and make this into a composite function and say that u is equal to 3x squared plus 1, and therefore y is equal to u squared. Okay, let's do the same thing we did before. So du dx is equal to what? 6x. And then dy du is equal to 2u, right? So in other words, again, dy dx would be equal to dy du dx. And this was 2u, which is this guy, times du dx, which is 6x, right? So this is going to be equal to 12x, 3x squared plus 1. Okay. Now let's go and do the straight dy dx and see what I get. Dy dx, if I go ahead and take the derivative of this, what do I get? I get 36x cubed. Over here I get plus 12x. So this guy is actually the same as this guy. Can you see that? Because if I pull the 12x out, what do I get? To pull the 12x out, I get 3x cubed, x squared, right? 3x squared plus 1, which happens to be the same thing here. Okay, again, I'm getting the same thing. dy dx is equal to dy du dx. Okay, so what we end up finding is, if you flip the page on 156, is in the green box. Okay. So in there, it shows you that the composite function f dot g, right? So if I take the derivative of f dot g, okay, I'm gonna get f prime g of x times g prime x. Okay? So in other words, I take the derivative of the function, the composite function itself, and then I take the derivative of the gx itself again, right? Okay? All right. So let's see how this works. Let's go ahead and do example number 3. Example number 3, I say, okay, so x of t is equal to cosine t squared plus 1. So I'm going to call this the t squared plus 1. I'm going to call this u. So x is going to be equal to cosine u. What am I trying to find? I'm trying to find dx dt. So this is going to be the same as dx du dt, right? Dx du, I'm going to take a derivative of this guy with respect to u. So it's a derivative of cosine, which was negative sine u, where u was t squared plus 1. Du dt, I'm going to take the derivative of this guy with respect to t. So it's going to be 2t. Okay, so this is going to end up being negative 2t sine t squared plus 1. In other words, right? So this is what I'm going to get. So I'm going to basically take the derivative of this whole thing, which is negative sine t squared plus 1. And then I'm going to take the derivative of the inside, 2t. Okay, you see how they're the same? They're the same there. Okay, so that's how this works. And that's how the chain rule works. Okay, so the thing that where you forget is you just take the derivative of this and say, oh, that's the derivative, I'm done. Okay, but well, you're not done. You're not done because you have to take the derivative of the inside again. And it'll be 2t, right? That's where the 2t comes from, right here. Okay. All right, so that's how it goes. So that's how we go from the outside, take the derivative of the outside, and then we go inside. Okay, so if you go to page 157, it says outside, inside rule. So you go from the outside into the inside, right? So if I ask you, what was the derivative of y is equal to sine 2x, right? I would take the outside derivative first. So it'd be what? The outside derivative is cosine 2x, but then I have to take the derivative of the inside, right? Now, if there was just an x here, I would not do the chain rule, but there's no need to, right? But since there's a 2x, I have to take the derivative of the 2x, which is 2. Okay, so the y prime is 2 cosine 2x, right? Okay, so that's how that works. The outside, the inside, right? Outside, you do the outside function first, and you do the inside next. Okay, so let's see if we can do example number 4. Example number 4, I have differentiate sine x squared plus x. I call this y, so y prime. Again, you're going to take the outside first, cosine x squared plus x, and then I take the derivative of the inside, which is times 2x plus 1. So my end result is this guy. Okay, all right. So you take the outside of outside derivative first, which is a sine, and then you go ahead and take the inside of it. Now the way that we were learning it earlier was what? So I would go ahead and say, I would say that u is equal to x squared plus x, right? And then y would be equal to sine u. Du dx is equal to the derivative of this, which is 2x plus 1. And this guy, dy du, is nothing more than cosine u. So dy dx is equal to dy du, dx. So dy du is this guy, cosine u, which is x squared plus x, times this guy, times 2x plus 1. It's the same thing, same result, okay? But we're doing the outside first and the inside. We do it that way. I don't have to go ahead and write down the u and the du, dx, and all that stuff. Okay? Now, sometimes you're going to have to use the chain rule more than once. In other words, you can have a composite function of not one function or two functions. You can have it of three functions, right? So let's see if we can do example number 5. Example number 5, I have find the derivative of g of t is equal to tangent 5 minus sine 2t. Okay, so again, g of t prime is equal to, I take the outside first. So the derivative of tangent is secant squared 5 minus sine 2t. Right, now I have to take the derivative of this, the inside. If I take the derivative of this, what do I get? This guy goes away. I'm going to get negative cosine 2t. And I can't stop here because I have another function in here, 2t. So I have to take the derivative of 2t, which is 2. So my end result is going to be negative 2 cosine 2t secant squared 5 minus sine 2t. Okay? Kind of complicated, but you just have to take it slowly and just work your way through. Okay? All right. So that's that. And let's stop right here. And then we'll finish it up later. So let's go ahead and start working on our homework.